Welcome everybody to the 950th meeting of the Amateur Telescope Makers in Boston. Amateur Telescope Makers of Boston. Of course, we were founded in 1934, and the group was devoted to telescope making, observing, and studying the heavens. Over the years, our club has grown, and in 1973, the Bond Astronomical Society merged with us to make us today one of the largest and oldest general interest astronomy groups in the country. So welcome to the meeting tonight. Our speaker is John Briggs, and he will be giving us a presentation about his wintering over at the South Pole Station. And so we'll get to him later on. Let's see if this thing all holds together here. So the agenda is the agenda that we always see. So I'm not gonna sort of belabor that because by now you've got that memorized. Next is a cartoon courtesy of Glenn Chappell via Julie Kaufman. That's pretty good. Most people are watching TV tonight instead of looking out at the sky. Glenn, are you with us?
I'm here. Can you hear me okay?
I can. Can you hear me okay? Glenn's the proud owner of a new set of headphones.
Yeah, it makes me look more official. I'm pretending I'm a NASA worker right now.
There you go.
Okay. Yeah, Julie's been sending a lot of cartoons as always. I appreciate her efforts. And we'll go to the next slide. We have our phrase of the month, and this is from Leslie Peltier, who was considered probably the top amateur astronomer, at least of the first half of the 20th century. And he wrote in his book, Starlight Nights, were I to write out one prescription designed to help alleviate at least some of the self-made miseries of mankind, I was thinking of what's going on now, it would be just this. One gentle dose of starlight to be taken each clear night just before retiring. And that was from Leslie Peltier. And if you've never read his book, Starlight Nights, I highly recommend getting a copy. It's basically his life story. And there's some powerful points in that. I remember I read his book to one of my classes one time, an astronomy class I taught. And the opening is him as a little boy looking out the kitchen window and seeing the Pleiades. And the final section of the book is about him going outside and seeing the Pleiades again as an old man. I started to choke up as I read that particular paragraph. So it's a beautifully written book. Highly recommend it. We'll go to the next slide now. And we have a couple of events going on. I'm going to preface this whole thing. This is tomorrow night. Guess what the weather's going to be when there's a relatively rare event? Looks like it's cloudy. You get that rainstorm, snowstorm coming in Saturday. So I think this is going to be clouded out. But what we're going to miss, it's Notburger. By the way, Mario, of course, an asteroid was named, or minor planet was named after him. And it was suggested we do the same thing for Bruce Berger. But somebody from the IAU objected strongly and said, not Berger. And somehow it was still transcribed. So now we've got asteroid Notburger. And it's magnitude 13.9. It's going to occult a magnitude 11.7 star. That doesn't sound like maybe a particularly impressive event, but if you've never seen something that's relatively rare, this would be a nice event. Again, it looks like we're going to be clouded out. If we weren't, you would see that star disappear for about 3 seconds as the asteroid occults it.
Hey, Glenn.
Yes.
So just make sure you tell your audience that it's not Eastern Daylight Time. It is still Eastern Standard.
Oh, we're still on standard. Okay, all right. It should be standard time now. We'll get to daylight time coming up all too soon. Thank you, Al. Anyway, we'll go on because that event probably will be canceled. By the way, I did fail to mention, if you look at the map, it's going to go from Canada right through the center of Massachusetts and out in the Atlantic Ocean. Now, the RASC has a bunch of observers up in Canada checking this thing out. We would have been stationed, and if you look at that chart, there is about 8:07. There's a 7 right over New England. That's when we would be getting this thing. Now, we need an observer out in the Atlantic Ocean a minute later, and so we're trying to get Tom to volunteer to take his sailboat out. There'd be about 1,000 miles off the Cape Hatteras there. There'll be 50-foot waves, but we think Tom can handle it. So we got this thing covered anyway if we get clouded out here. Now we'll go on.
Well, here's the finder chart for it, Glenn.
Yeah, nice. You see all the bright stars right there where the X is. It's in between Auriga and Perseus, and I made some notes on this. Let's see. It's not too far from, let's see. It's a 5th magnitude star called 53 Persei. So this, yeah, you're going to have a little skill of finding things to locate this particular thing. And we'll go on.
It's probably
Again,
just
we're
as
gonna-
well. It's going to be cloudy. And thank you, Al, for pointing out my, I've been off by a week on daylight savings time for about 2 weeks. So I
Yeah.
think we're already in daylight savings time, but apparently we're not. It's this weekend coming up. Yes. I
That's
believe it's
it,
this
yeah.
weekend. Perfect. All right. I'll have to fix all my clocks again. Anyway, here we go.
Yes, actually, it's a double gut punch we get. We've already talked about Friday, March 11th, tomorrow night. Daylight saving time begins, so we have to wait an extra hour to do our observing. That happens Sunday morning at 2 a.m. Tuesday, Eta Leonis is going to be occulted by the moon. It's a 3rd magnitude, 4th magnitude star. Unfortunately, well, besides the fact that we'll probably have clouds, I know I sound like Eeyore right now, but we're going to have a very bright moon. It's going to be 3 days prior to full moon, so it's going to be pretty bright. But it's worth a look-see with binoculars and so forth.
I will
Vernal
say, if you have,
Equinox.
I was going
Go
to say,
ahead.
Glenn, if you have if folks have a telescope aimed at the moon, even on the bright, even with a bright moon like that, a magnitude 3.5
Yeah,
star will be pretty easy to see in your telescope, especially as the dark limb of the moon approaches it. If you've never watched a stellar occultation, you should really treat yourself to this one. It gave, these types of events gave evidence that the moon had no appreciable atmosphere, because
Mm.
if you've never seen one of these things happen, the star is at full magnitude all the way until the knife edge that is the limb of the moon cuts off the star's light, and they literally wink out. If you blink, you miss it. It's pretty cool to see. And when you get a bright star like a 3.5 magnitude star, it's pretty impressive. So I wholeheartedly recommend that one. And I think it will be Eastern Daylight Time by then. So I think I'm good there. The vernal
Yes.
equinox, like you said, Glenn, is on Sunday the 20th.
That's another gut punch. The nights are getting darker later, so we've got the daylight savings, the vernal equinox. I want to get back to that occultation. It will be the dark part of the moon that occults the star. If you've never seen an occultation before, it's kind of neat. If you have a high power in a telescope, it almost looks like the moon is still and the star is just a little bomb going down, then blink, it's gone. The tougher part is going to be the reappearance, because it will be a bright moon, and you never know exactly, you'll be looking and looking. I don't think I've ever actually seen a star reappear without, I blink and I look and there's the star, but seeing it disappear is a little easier because you can see it getting closer and closer, and then blink, it's gone. It's amazing.
Yeah, they're fun to watch.
Yeah, now we go down to the 20th. Venus reaches greatest elongation in the morning sky, 47 degrees west of the sun. And Rich brought this out, and I happen to subscribe to a neat little newsletter. I don't know if you can see it if I hold it up, but it's put out by the Abrams Planetarium. It's called the Sky Calendar, and on one side they have little sketches for pretty much every event, so you can look very quickly and see where you're going to be looking and so forth. The backside has a map of the sky, and I think it's $10, $12 a year for a subscription to the Abrams Planetarium. But anyway, as Rich mentions here, there's going to be kind of a neat gathering of the planets, Mars, Venus, Mars, and Saturn in the morning sky, east-southeast sky, very low. And it's going to be really, I'm looking here at this one, and from the 24th right through the end of the month, Venus is going to kind of scoot basically above Saturn. It's going to be to the right of Saturn. It's going to move above Saturn and off to the side. And that leads to another event that's coming up. All three on March 28th, will be visible in the wide field binocular, and there'll be a very thin crescent moon to the south. So the crescent moon will join this whole group. So it'll be very nice naked eye sight. I think we've got some more.
Just a few more.
All right, we have a new moon coming up. Mario will be very happy about that. And on Tuesday morning on April 5th, Saturn and Mars are going to be just a half degree, less than that apart, low in the south-southeast sky a little bit before sunrise. So that'll be a nice event. Again, it's going to be low, but if you've got a nice open horizon to the south-southeast, you'd have a good view of this. And finally, on April 9th, bad news again for you, astro imagers. The moon will be at first quarter and getting brighter every day. So middle part of April is going to be kind of washed out for you astro imagers. Continuing.
Click.
Okay, the Observer's Challenge for this particular month is, it's a Bell, not NGC. I'm so used to NGC and Messiers. This is a Bell 21. And when I saw a Bell, I thought, uh-oh, we are in trouble. And this object wasn't even discovered until 1955. But back then, amateur astronomers didn't have O3 filters and narrowband filters to help them out. And I know that it's right, not too far from the star 6 Canis Minoris. I did try on 2 separate nights and I struck out. I have to admit, I couldn't see it. I knew exactly where to look. I knew exactly what I was looking for, and I just wasn't having any luck at all. Our friend Roger Ivester, who's of course the one that started the Observers Challenge, he picked it up after about 4 nights of trying. And I know, Rich, you said you tried at the clubhouse with Steve's 18-inch, but I'm wondering, is anybody that they can kind of chime in here? Chris, I thought you said something that you probably saw it visually. Can you chime in on that?
Yeah, I was borrowing Steve's telescope that night. And actually, my son is the one who said he could really see it. I was kind of getting the faint, like it's a little bit brighter area. And Steve's on, I'm sure he can chime in more.
Steve there? Probably, it's a toughie. It's
Hear
a
me,
toughie.
yes.
Yeah.
Okay,
it's,
what
a,
was,
it's a tough one. I've seen it twice before under very good conditions, particularly when it's very high in the sky. And you do need the filter, needless to say, either a UHC narrowband or a line filter, O3 filter in the 18. And it's kind of large, so you can't really jack up the magnification too much, at least not in my scope. So it does help medium magnification. I think we used a 10 millimeter ethos that night, and I saw a hint of it, perhaps, but I couldn't swear to it this time. My eyes are about 6 years older than when I last saw it, so it's going downhill every year. It's a tough one. It's a tough visual challenge.
It took 4 hours of imaging in order to get a good picture with the 32. So visually, it's got to be tough.
And Mario, there's yours.
Mm-hmm.
So that's
okay, we'll go through and look at the pictures here. And Mara, if you want to give us some background on this image.
Yeah, this is taken with the 32. It's 2 hours of hydrogen alpha, 1 hour each of oxygen and sulfur. So got a tricolor image of it, but it's very, very faint. The subs are barely above the noise. The hydrogen alpha shows it off better than the oxygen and sulfur, but to get the color, you really got to get all 3. And I took this, I think, back in December. So I stayed up late one night and managed to get it.
Mm-hmm.
yeah, it's a pretty large. I'm just looking up the size of it right now.
It's 11 arc minutes across, something like 11 or
Yeah,
12 arc minutes.
Sky Safari Pro has it as 12 by almost 9 arc minutes. So it's
That's a third
fairly,
lunar diameter.
yeah, fairly large object. Well, here's a shot by Mark Helton. Mark, are you on? You want to talk about that at all? Maybe he's not home from work. All right, it's very lovely.
No, I'm here.
Oh,
I'm
There
here.
he is. There he is. Hey, Mark.
Let's see. I think that was 25 300-second images with the Optolong L Extreme filter, and this was with my ZWO 533 camera. So
It's very pretty,
yeah,
very nice.
I was surprised I found it. It took a lot of processing too I see what Mara says, that's, you know, I got mostly the hydrogen alpha. You can just barely see the bluish, I think that's oxygen, right? Blue is blue oxygen, or yeah. And you know,
Yes.
the full color cameras, obviously you can only pull so much of the color out. But yeah, I was happy to find it. It's for my scope, it's not super big. So yeah,
Well,
it was cool.
though, whenever I look at a picture that shows red like that, if you're telling me that's H alpha, my first filter I would go to the UHC filter for that. The Oxy 3 might be a little too restrictive. I would try a UHC filter first, see if you could pick it up visually. And yeah, I would expect to see the brighter hydrogen out, the ionized hydrogen areas.
Yeah, my next jump in astrophotography is going to be doing multiple filters. But
Very good.
for now, we're full color.
All right.
Anyway,
Thanks,
thank
Mark.
you. Yeah, thank you.
This one's by Doug Paul. I don't know
Is
if
Doug
Doug's
there?
on.
He doesn't use Zoom.
Oh, okay. Well, then let's press forward. This is Chris Elge's shot. Chris, was this with the middleman?
Yeah, this is the middle. There's no way I get this at anything other than the middleman.
Look at that.
Wow,
Look at that.
That's very impressive.
Look at that.
Yeah,
Man.
no, this is an hour of each narrowband Hubble palette mapping. Now I did normalize the different channels so they all had a similar median. So that's why they brings out the O3 so much, is because they're all normalized. But yeah, no, I don't know how it had so much data. It was just sitting right above the noise floor, because even that outer area is visible. And when I was processing this, I was like, I really wish I had taken more time on it, because all that I could have probably gotten it out of the noise if I had had more time.
That's beautiful.
I'm
My
just
goodness.
amazed. I'm amazed at how many stars you can see with that.
I know.
scope.
Look at that.
I mean, I look at that compared to my scope, and I'm just amazed at the.
What's ridiculous is this is narrowband, remember? So those stars are dramatically reduced.
Right, but boy.
I think this
That's
is like
fantastic.
an f4.6 telescope, so it's 17-inch aperture, so it pulls a lot of light in. It's also been 2x2 on the.
Chris, that's a really incredible image.
It is.
Well,
Well
that
done.
middleman is doing a good job.
Yeah.
Well
Nice.
done.
Well, thank you everybody for that. Glenn, there's one more slide, remember?
Yes, there is. I want to say beforehand, I am an old-fashioned visual observer. My imaging equipment is a notepad, a flashlight, red filtered, and my eyes and a pencil. But this is astounding, and I've said this before. I look at the pictures that all of you are taking, and you look at my astronomy books from the 1960s, and these are better than some of the top observatories in the world from back in the mid 20th century. It's just astounding stuff. So keep it up. And what I wanted to bring up here, I thought might be time for me to start giving a preview of what's coming up next month and just send out a message to everybody. The April challenge is going to be NGC 3079. It's a galaxy in Ursa Major. This is a Hubble image. And in the middle of that galaxy, there's a super bubble. And it was thought that this is either caused by maybe a large black hole or an incredible amount of stellar formation. And what I wanted to remind people, and I had to write this down so I remember, please send your images, any notes, send them to me, and I can get them into the article that goes in our newsletter, the article on the Observing Challenge. I try to get that to Al at least a few days before the end of the month. So if you want to see it in the newsletter with my article, send it to me before in this particular case, before the end of April, before the end of this month, rather, before the end of March. And if you want the images to reach the OC report like these are, just get them before the next meeting, and again, a couple of days before, so I have a chance to send that over to Rich. And I'd still encourage a lot of you, some of you have been doing this already, send your work directly to Roger Ivester. His email address is right at the end of these articles in the newsletter, and they do get published on his website. So 3 options. 1, send it to me for the newsletter by the end of this month for this particular galaxy, before the next meeting to have it in the OC report. And by the end of April is when Roger starts to tabulate this all. So please send your images on this particular one, or sketches if you're a sketcher. And again, I want to thank you all for your efforts. I want you all to stay healthy and keep looking up. Thank you very much.
Thanks, Glenn. Much appreciated. Always enjoyable. Our speaker this month, let me read this. I'm going to move some stuff out of my way so I can see it without, there we go. So our speaker this month is John Briggs. John has lived and worked at far-ranging observatories in various technical capacities, including Mount Wilson, Yerkes, National Solar, Maria Mitchell, Venezuelan National, Chamberlain, and the South Pole Station. He came to New Mexico with his family in 1997 to assist in the final commissioning of the Sloan Digital Sky Survey at Apache Point. In the 1980s, he was an assistant editor at Sky and Telescope magazine and built Bogsucker Observatory in Massachusetts. He is a member of many astronomical organizations, including the Springfield Telescope Makers, responsible for the annual Stellarphane Convention in Vermont, and he serves on the board of the century-old American Association of Variable Star Observers. His principal activity now involves the Astronomical Lyceum, an informal museum, library, and laboratory and lecture hall devoted to historical astronomy and its preservation, and his role as secretary of the new Alliance of Historic Observatories. John is well known in New England, and I expect elsewhere also. And so, John, thank you so much for giving us your time this evening. And I know everybody's muted, but I'm sure everybody's now giving you a muted round of applause
That's all right.
to welcome you. You should. I'm going to stop sharing my screen. Then I should, you should be able to share your screen. And
John, I just want to say one thing. When you were in Antarctica for those 2 seasons, you used to send emails to me and the kids, and those got posted all over the Linfield school system over and over again. So
I hope they were in reasonably good taste. In
they were.
contrast to what I'm like.
You were a big hit in Linfield and a big hit with the kids.
Yeah. Okay. Great. No, thank you for reminding me about that, Mario. I'm going to go ahead and try sharing, and let's see here. I can be a real moron with this technology. Let's see, full screen like that. And do you all see that picture of Yerkes Observatory?
I do see that.
Excellent, excellent. I'm going to minimize that thing. Okay, it means really a lot to me. It's very happy thing for me to be able to join you at this meeting and to be able to share with you. I was lucky. I'm a native of Massachusetts, and as a young man and hardly more than a teenager, I was able to take advantage of the club's activities going back into the 1970s. And I've made so many friends, have learned from so many of you. And I could go on and on trying to wax philosophically about how much I appreciate knowing you all. But I got a lot of pictures to show you, so I'll try to stifle myself on those emotional things, heartfelt as they are. I will only mention that I thought it was very nice hearing about how many new members you mentioned just in the introduction tonight. And if you new members of the Boston ATMs can enjoy the fellowship as much as the rest of us, so many of us have over the years, you have a lot to look forward to. But what I'm going to try to share with you now is I'm going to lead you through a year, nearly a year, living at South Pole Station, as I had a chance to do back in 1994. And a lot of people realize I'm interested in history of astronomy, and this talk, it's really of the greatest adventure, astronomical adventure in my life, having this experience. But it's become historical itself because 94 was a long time ago. But anyway, I should get into it. Well, this is Yorkies Observatory. And of course, Yerkes, if my slide, let's see, it's not advancing. Let me try this again. It is not advancing it usually. There we go. Okay. Yerkes Observatory of University of Chicago is especially famous for the 40-inch refractor there. To this day, the largest refractor in the world. But back in the early 1990s, it became headquarters for this organization funded by National Science Foundation, Center for Astrophysical Research in Antarctica. And it was a collaboration that involved many institutions, and it was funded by NSF for over a decade to explore the potential of the South Pole Station for astrophysical observations. And so they hired a number of people that seemed to be like appropriate red meat to get involved, spending time in Antarctica. And I'm afraid I was one of those people. So I want to take you there. And so what's it like to get there? You would fly via commercial airlines to New Zealand, a beautiful place, Christchurch, New Zealand, the city on the South Island. that has a facility called the International Antarctic Center. And in that building, right beside the Christchurch Airport, you'd be outfitted with the appropriate clothes. They will have sent them your measurements and things all ahead of time. And depending on what you're doing, you have put in a great deal, typically, of preparation for the trip to Antarctica, because you're going to be operating some equipment or engaged in some sort of scientific campaign. And maybe you've undergone certain testing and training. And certainly during a winter over, there was essentially some psychological testing and special training, and I'll allude to that. But anyway, when you get through all of that, eventually with your issued extreme cold weather clothing, you get on an LC-130 aircraft and you fly from Christchurch to McMurdo Base on the coastline of Antarctica. And it's a 7.5-hour flight, and it's a military style aircraft, turboprop, big turboprop, without many windows, and you typically fly in with a lot of cargo. And eventually, as you approach McMurdo, for a while, you fly over the Trans-Antarctic Mountains near the coast, and there are gigantic glaciers like these, and the crevasses that are there are big enough to swallow an entire house or a typical New England building. Of course, people go to Antarctica to study glaciology and all manner of things, from penguins to walruses to cosmic microwave background radiation, all manner of things. But I took a lot of pictures looking down in wonder at the glaciers, but I'm only showing that one because our point is to get to McMurdo and on to South Pole. Well, here I am standing in front of the aircraft, trying hard to look cool. And back in younger days, glory days, and I got the slide back and back in civilization at one point, and I held it up to the light and I looked at it and I was pleased because I had a memento in this image of being cool down there, literally and figuratively. I passed it to my engineer friend to show it off to him, and he said, "Yeah, Briggs, well, couldn't you at least have gotten your shirt buttoned straight?" Well, I didn't, but I learned how to manage those things later on in the experience. The important thing to point out to you, of course, is the interesting configuration of the aircraft. See how it has skis. That's what the LC-130 designation refers to, that this type of C-130 is one of the relatively few that exist in the world that has skis that can lower below the wheels, because the aircraft is actually landed on sea ice here. So it's not on land in the appropriate season of McMurdo Base. So you typically will spend several days in McMurdo waiting for another flight to carry on to South Pole Station. And here is another one of these aircraft landing on the high Antarctic plateau, literally at the geographic South Pole. It's another 3.5 hour flight from McMurdo to South Pole Station. And it's quite an experience, and because of course there aren't many windows on these military style transports, but you are free to go up to the cockpit and look out with the pilots. And so you have a chance to be there to look down on the vast frozen wasteland of the high Antarctic plateau, flatter than Kansas, frozen white like a gigantic ocean with just nothing visible before you, except eventually there it is, a tiny dark spot on the horizon and you approach it in the middle of all this white, that's South Pole Station. You have to go back and sit down and you land, and there you are at this minuscule place compared to the vast expanse around you. What's the deal with the flags? Well, look, there's like a chrome sphere there on a bamboo pole, but that is not the real geodetically surveyed South Pole spot. What the picture shows is what they call the ceremonial South Pole. The real South Pole is several hundred yards away, depending on what year you're talking, because actually the ice is moving relative to the Earth. And so the geographic South Pole has to be restaked every year to be approximately right. In any case, this spot is the ceremonial pole. It's not the real one. The base maintains a large inventory of every imaginable political flag. So depending upon what political dignitary may be visiting the base, as can happen during the Antarctic summertime, they can make sure that, that one of the appropriate flag is out there. So a visiting dignitary can be photographed with his flag in the background. Of course, there's a US flag there on the far left. But if you want to be photographed beside the real South Pole, well, that's gonna, you'll see that in another picture later on. And that only has one flag there, the US flag, because it's our tax dollars that are paying for the operation of this base at South Pole Station. And so we hold the real South Pole in reserve for the US anyway. So you tumble out of the aircraft and step to the base center, and you look down at the open front door and you read the sign. It says, "The United States of America welcomes you to the Amundsen Scott South Pole Station." And you sort of do a big gulp, because you realize, well, this is, I'm beginning what is going to be a winter over. I'm going to live here an entire year. What's it going to be like? There's really no much turning back. But in any case, it's a very exciting thing. What is historical about this presentation is that the nature of the main base has changed tremendously since I was there in '94. Nothing of the giant old geodesic domes exists anymore. It's been all re-engineered and rebuilt to be more efficient. And I'll speak a little bit about that as we go on. But let's see, let's keep going. There we go. So, so at least I can tell you about what it was like as it was. So inside the dome, it's 160 or so feet in diameter, or at least it was. It's nothing more than a wind and blowing snow shield. The heated buildings are these orange, red ones inside, and that's me on the left and one of my Winter Rover friends. And of course, this is an extreme wide angle. It's a lens, 9mm focal length Nikon fisheye with a 35mm camera. I shot almost all these pictures on Fuji Velvia ASA50 film, fine grain film. And so there's extreme distortion. The bright spot in the upper right is actually a perpetually open air ventilation aperture at the very zenith of the dome. So it looks like it's on the side, but actually that was straight over our heads, as I will have reason to explain in just a minute. Notice the building on the right-hand side has these white doors. They look like meat locker doors. That's because they are meat locker doors. And it seemed to me that the management was quite enthusiastic, because the meat locker doors were at that time a relatively new installation for safety. Because that's actually a dormitory there on the right-hand side, and every dorm room had an emergency escape meat locker door. Because if you want a door in Antarctica, you buy something like a nicely insulated meat locker door. And if you can put one, say, at the head of your bed, if there's a catastrophe, like if fire breaks out, a meat locker door at the head of your bed facilitates jumping out of bed in your underwear or whatever, right out into the Antarctic cold. In any case, they were nice to have. I never really had to use it, but I'll keep going. Looking straight overhead with something of a telephoto, there's the aperture, the ventilation I was referring to before. The geodesic dome is aluminum. Of course, it's all, I should be using the past tense. It was aluminum. And each of those apertures is about 3 feet in diameter, and they allow humidity, really, smoke, humidity from human activity, the kitchen, and all that to just escape from the dome. But in so doing, the relatively moist air, some of it passing near the aluminum structure, allows gigantic ice crystals to form, and they're quite spectacular. And it dramatizes really the battle at a place like South Pole Station with ice crystals and frost, that was very important to why we were there, as I'll get into. But I think I'll just keep on going. It was possible for me to climb up the outside of the dome, and that's what I've done for this shot. I'm looking down through one of those holes, and then I've got 2 of my friends to be spread eagled there, making snow angels to dramatize just where I would have splattered if I'd happened to slip through the hole. I'm laying on my belly there with the camera and lens, and the shot at least dramatizes how there were, in fact, 3 heated buildings inside the old geodesic dome. The one on the lower right was a dormitory building, and you can see a lot of those white meat locker doors. One of those was to my dormitory room. The building on the left was sort of mainly an administrative center, communications building, meteorological laboratory, additional general lab space for electronics tasks, and a little bit of recreation facility, like a room to watch videos. The building on the top was mainly a galley, another in the kitchen, and the upstairs was something like a bar room environment, again, for recreation, and an adjacent second video room, so that if there were 2 populations of interest at one point in time, like perhaps one group that wanted to watch Ren and Stimpy videos or something, and somebody else wanted to watch, I don't know, a PBC video recording or something, well, we wouldn't have to fight so much with each other. And you could judge for yourself what group I might have been in. You can't get satellite TV at South Pole Station. They don't bother to project geosynchronous television energy to South Pole. So we were very much on our own in terms of having videos and things to watch recreationally. Now, although I'm going to try to take you through in a chronological way through the winter rover experience, this shot is a little bit out of sequence. It's a shot of showing inside the galley and in the dining area. And this is actually during the middle of our winter rover, when there were only about 27 people, as I recall, a skeleton crew. During the summer, when the airplanes could fly in and out, we would have as many as 140 people on base, setting up equipment, doing a new construction and other maintenance and all manner of things. But during the long winter rover, when it's too cold to fly in and out, it's a skeleton crew. And that's why the people here in the middle of the winter might have especially long hair maybe a little greasier than they might be otherwise, but showing the more earthy nature of the winter rover experience, maybe. Well, that's the way it was. Here's my dormitory room. Now, in order to get the whole picture in one exposure, I've stood on top of a chair with a 17mm lens, and I'm capturing the whole room with my head and camera at the top of the door frame. And there's not much to the room. Like I described, there's the emergency escape hatch at the head of my bed, but I am compelled to explain. You'll notice the graffiti on the wall. The wall has been tagged. I was not responsible for doing that, but I was responsible for spending essentially a year living in this room and never getting around to painting it over, and consequently spending way too much time wondering what was going through the head of the previous winter rover person who drew that art, who made that tag on the wall instead of just painting it over. But anyway, it was fairly Spartan, but it was really actually comfortable enough, because the fact is they've really got it down to a science how to live relatively comfortably at South Pole Station nowadays, in contrast to the times of Amundsen Scott in the early 20th century, the first time human beings made it there. Okay, this fellow was Ed, our winter over chef, and he is standing near the inside circumference of the dome, and behind him is the chimney-like emergency escape tower, that if something really bad, like a big fire broke out in those heated buildings inside the dome, you could get the heck out of the dome by climbing that ladder. But somewhat analogous to the irony of getting out of your bed into the cold inside the dome, well, it'd be maybe even worse climbing out of the dome into just the native environment of South Pole in a bad emergency. But nevertheless, we have these avenues of escape. You'll notice at Ed's feet, there is quite a significant tongue of snow, because there was a hatch at the top of this chimney that had been left open. So some blowing snow had fallen down the chimney and accumulated inside, making that tongue. The aerodynamic effects of windblown snow are an interesting issue at South Pole Station, and I'll talk a little bit more about that. Beside Ed, I should point out to his right and left, so many cardboard boxes, profoundly frozen cardboard boxes. Almost all of it was leftover extra food from previous winter over seasons. And Ed was aware of the food inventory. He pointed out to us that, in fact, he figured that if airplanes never came back for us, we would have had enough to eat for about 7 years. The problem, of course, was, well, there were two problems. One, we would have run out of heating fuel long before 7 years would transpire. And also the things that were left over tended to be disreputable things, like say okra. There was a big stack of cardboard boxes near the stairway I had to climb to my bedroom, and they were all labeled okra, profoundly frozen okra. I don't think we ate any the year that I was there, but we did try to do the very best job we could, eating the king crab legs and steaks and all manner of things. The National Science Foundation tries to maintain morale by having a well-qualified chef and some pretty nice food to just minimize something that you might otherwise become depressed about in the inevitable odd psychological evolution that everybody experiences during a winter over at South Pole Station. They worked very hard to make the food good, is what I'm trying to say. Okay. From the outside, there was a tower near the dome that was intended for ionospheric studies, monitoring the aurora and things of that nature. It was a nice tower with there were nice rooms in it with picture windows, so it was a fun place to visit. Typically, a very quiet place to go and relax, and also just made a nice view looking back at the giant dome. But as you see here, there's been a lot of excavation of snow around the dome because the wind-blown snow would tend to bury the dome. And the dome, of course, had limited strength. So they went to a lot of effort every once in a while digging it out again. The precipitation on the Antarctic Plateau, well, by the way, our geographic altitude above sea level here was 9,301 feet, according to the sign beside the geodetically surveyed South Pole Monument. The snow accumulation every year was on the order of 4 to 6 inches only, according to what people told me who knew about it. And they surveyed the natural accumulation at sites far removed from the human activity here and the building structures that, but because of the aerodynamic effects, would tend to affect the natural snow accumulation. The point being is that it doesn't snow very much at South Pole, but there's many ice crystals in the air all the time. It's wind blown. But if you build something on the ice, it tends to get buried by blowing snow due to interesting aerodynamic effects. But I should keep going. This cavernous structure was really quite near the dome, but it was mainly all buried. And so what is it? This was, and there were more than one big caverns like this for various functions, but this one was our main fuel storage. So how do you heat South Pole Station for a winter over? Well, let me just point out with the mouse if I can. Okay, here, if you can see my mouse moving, I'm drawing a circle around something I hope you can see clearly. It's actually a person, and his arms are spread to the right and left because he's laying down with his head towards us and his feet away from us, and his body is on top of something that is effectively like a giant waterbed. But it is not a waterbed, it's a fuel bladder. And I don't know, your guess is as good as mine. That's 25 or 30 feet square, and it gets several feet tall when it's inflated with aviation fuel. So during the summer, as I recall, they have enough time for about 140 flights from McMurdo to South Pole Station. With each flight, the aircraft, upon arrival to South Pole, has a surplus of diesel, of aviation diesel. With an appropriate safety margin, the surplus is downloaded into fuel bladders like these, and it puffs them up and gets them full by the end of the summer season, which is about 3 months long. Let's count the fuel bladders. 1, 2, 3, 4, 5, 6, 7, maybe 8. I can't remember, but it's a big building. And if you notice here, there's another person that I'm circling right now, a long way away from me when I took this picture. And there was like a sidewalk like this going down, and somebody's walking away from us. So it's a lot of fuel bladders. There were a few spare bladders located for safety away from all of these. So there's something bad happened to these, there would be other fuel bladders to draw from. They powered, as you can imagine, a diesel electric generator. There were actually 3 of them, great big generators only one of them on at any time. The second one available for instant backup. And the third one basically being rebuilt so that you'd swap out and cycle through each of the three large diesel electric generators. It was sort of like going into an engine room on board a ship. And that was in another part of the base. So we'd have electricity, but also the exhaust going up from those diesel electric generators. There was a glycol loop in the great big exhaust smokestack, and the glycol would get cycled through like water in a radiator, and it would be pumped around the station, and so you'd some of that waste heat from the exhaust was in fact captured by this glycol loop, and would benefit and heat a lot of the station that way too. So there are all kinds of fascinating logistics to make the place livable. And I only understand a little bit about those details because they were not my job. But in the 27 person crew, there were specialists for all the maintenance of all these details. This was a special shot and time. See the contrail, the cloud in the sky. It's actually a contrail because that's the trail of the last airplane of the summer season, and it had left to return to McMurdo. Everybody on the station, the Winter Rover crew, had come outside to watch that airplane fly away. And I took pictures nosily of my friends' faces. And everybody had a fairly serious expression. We all did, watching the plane go away, because it's a rather thoughtful time, because that plane's gone, and we have begun the Winter Rover with the departure of that plane. And you're wondering, well, what's it going to be like? And am I going to be able to manage this satisfactorily? Well, what did we do that day? Well, I describe this as my zombie apocalypse shot, because everybody is sort of waddling back, converging on the station like so many zombies. What did we do? Well, we converged on the station and we threw a party. We broke out the beer and we broke out videos. And as a crew, we watched both versions of The Thing. Not only the 1950s version, where the alien monsters thaw out of the ice up in the North Pole somewhere. And you know what they do? They ate everybody. And then there was the 1970s or early 80s version of The Thing, which should have been rated X for violence, directed by John Carpenter. And again, what did the monsters coming out of the ice do in Antarctica? They ate everybody. So it was a fabulous way to festively start our Winter Rover with a good party day. And it was actually quite relaxing now to finally get the very congested summer crew completely out of our hair and allowing us to live and relax with a little bit more elbow room. Now let's take a look at a few of the people and doing their jobs. We had two ladies serving that year as Winter Rover meteorologists. This gal was named Anne, and she's with an interesting sort of antique instrument. My attention was always attracted by old instruments like this. And there's actually two of them, and you don't normally need two of them, but it's like a crystal ball. See, there's a glass sphere there, 4 maybe 5 inches in diameter, and behind the glass sphere, it's effectively like a sundial, but instead of something casting a shadow, it's a sphere of glass that is focusing at very short focal length an image of the sun on an interchangeable slip of special paper. So what does the instrument do? Even in the cold Antarctic temperatures, the focusing power was so great it would make a black mark on this paper during clear hours. So in a completely passive way, the instrument would record clear hours. But the issue is at South Pole, the sun is not setting in a daily basis. It's only ever so slowly moving up in the sky as it goes around, or maybe eventually moving down in the sky as it moves around. So you need two of these things, one facing the camera more or less, and the other facing the other direction. Between the two of them, they'd record sunny hours all day long. Of course, Anne and her meteorologist colleague had much more modern instrumentation than this, but I just thought it was cool. And naturally, they paid great attention to maintaining records of everything meteorological down there. This fellow was named Brent, and he was our principal communications engineer. This dish was directed to a geosynchronous satellite. Was actually an old geosynchronous satellite that was subject to a fair bit of declination drift. It was not stabilized on the equator like the younger geosynchronous satellites are, but for maybe about 6 hours a day, this particular satellite would drift far enough into the southern sky, into southerly declinations below the celestial equator, that it would be several degrees above our apparent horizon, because of course the horizon at South Pole Station is the same as the celestial equator. In any case, we only had access to this one sort of lame and old geosynchronous satellite. This gave us access to the internet, but we only had it for a handful of hours a day, and it was flaky. If there was a lot of blowing snow or something, we could not connect with this satellite. But I do remember one thing in '94, our information technology guy in his lab, he called me into his lab one day. He was sort of a quiet, shy guy, but he said, "Hey, John, come in here. I want you to take a look at this. You might find this interesting." And I went in, it was just me and him. And he said, "You know, look at this on the screen here. Have you ever seen anything like this?" I said, "No, I didn't. What's this?" He said, "John, this is what they call a web page." So it was the first time I saw a web page was over that satellite link at South Pole Station. The times have changed a lot since then. But my point is that communications could not be taken for granted in '94, and I bet you even to this day, communications from South Pole Station are surprisingly primitive, even with all our modern technology. Okay, so here's a Winter Rover science technician named John, and he is standing on top of actually a seismograph station. And he's looking like the angel of death there, or maybe he's actually going to be sort of like a scientific Santa Claus, because actually there's a shack that has been completely covered with windblown snow, and it's got the seismograph inside the shack. But as the small building got covered with blowing snow, they built a chimney on it. And so you'd go to the chimney and you'd go up and down the chimney to get to the experiment and maintain it. So that's why I'm calling him a scientific Santa Claus. Look at the funny aerodynamic nature of the wind-blown snow. It's like that because the wind at South Pole Station is blowing almost all the time out of one particular direction. It has to do with the ever so slight slope of the land, or I should say of the ice. The cold air is rolling downhill towards the coast, typically at about 12 miles an hour from higher altitude to lower altitude. The higher altitude and the colder air, where it's coming from, is off to the left in this field of view. But anyway, I think I've got another shot because I'm going to take you down inside one of these things. But this one, they didn't get a chance to build the chimney up recently. but John knew where it was, and he knew where he had to go and dig it out a little bit to expose the chimney, or at least the hatch. So here he has exposed the hatch and he's got it lifted away, and he is exhaling, and he looks like a dragon snorting, right? And the thing is, with every human exhalation outdoors at South Pole, there would be a big cloud of condensation like this. So most of the time when you're taking a picture of someone, they know to hold their breath as part of the picture taking process. But in this case, I wanted to dramatize it. So I said, John, snort out a big breath for me. And he did so. Behind John, you see there is a rope line and flags on bamboo poles. One of the winter over tasks before the sun went down was to lay out the flag lines and the ropes. The idea being is if a guy like John goes down into an experiment like this and spends some time with it, there's a chance he would come back up and the atmospheric conditions could have changed dramatically, and suddenly he could find himself in a complete whiteout. And so where you could not see anything with blowing snow. So the idea was any place there would be human activity to have a safety line that you could follow that rope back to the base center. So anyway, that's what that rope was. We had them all over the place going out to the various experiments, including where the telescopes were. But anyway, let's go down. And so here's John down at the bottom of the chimney inside the little cabin. And of course it was unheated. And talk about the being on the inside of a refrigerator that profoundly needs to be defrosted. The actual seismograph was in a small box that was presumably heated somewhere. I don't even have a photograph of the seismograph because that's not what interested me. What interested me was just the environment in there. And there you get a sense of how tall that chimney was in this case, again, because of wind-blown snow in this structure on the just exposed outdoors. And I was fascinated with the ice crystals. So I took off my glove, and so you'd have my fingers for reference, just the scale of the ice crystals. Interesting how they form. Once you got down into the snow like this, the temperature was a very, very constant -50 degrees Fahrenheit, because -50 corresponds to the average temperature year-round at South Pole Station. The snow itself is a marvelous insulator. So it's very surprising how if you bury something just down a little bit, its temperature will not change from the -50. But further, if the air, of course, has any trace of humidity in it, in a situation like this, when a water molecule comes in contact with the walls, it sticks and the ice crystals grow. So in a sense, this is a dramatization of how it is that the air in Antarctica is profoundly dry. It does not mean it isn't occasionally 100% humidity. Interesting. For its temperature, the air can occasionally be quite saturated with moisture, as 100% humidity defines. But at these very low temperatures, 100% saturated doesn't necessarily mean there's a lot of water in the air. The reason we were at South Pole for astronomy and for the radio astronomy was water vapor absorbs a lot of wavelengths. Near infrared wavelengths, however, are severely attenuated by water vapor. Certain microwave wavelengths are similarly absorbed by water vapor. But if there's hardly any water vapor in the air, you get a clear shot in certain infrared wavelengths around 2.3, 2.4 microns. and also in certain microwave radio wavelengths, for example, where the cosmic microwave background is observed. So it was the dryness of the air, which was the attraction of South Pole for us, and as I'll explain. But a couple of other guys, these fellows were launching a weather balloon, but a special one. They're preparing the payload here at the end of one of those big archways that open kind of like a garage door. And it's actually an ozone sonde, is what they called it. And it's the same two fellows. The guy on the right has the easy job. The guy on the left has the harder job, because the guy on the right at this point, all he has to do is let go of the balloon. The guy on the left has to avoid getting the $3,000 price tag ozone sensor. They called it an ozone sonde, because as the balloon goes up to something like 80,000 feet, that sensor sniffs out the percentage of ozone in the atmosphere around it. And so it was a way for these guys to monitor the ozone hole, which was getting a lot of concern and publicity back then as it came and went over Antarctica. So anyway, the guy on the right lets go, and the fellow on the left, though, has to run along under the balloon, because he doesn't want that ozone sensor to go bumping along, dragging on the ice until the balloon is all the way up, and then he can safely let go of it, and up and away the balloon goes, and nobody's ever going to get it back again. But as it ascends to its high altitude, they happily get the radio recording back of the ozone concentration and write it down. And maybe 2 or 3, 1 or 2 other times every week, they blow through another ozone sonde, but they sure don't want to waste them. But that was the way they were monitoring the ozone hole. It was among the ways they did it, at least back in '94. I should point out that in the lower right, the big blue box, that's actually a fairly large building. Remember, the communications engineer was beside a big dish? Well, there's the dish. I was standing on top of the building when I took the picture of that guy messing with the dish. But that is one of the newer buildings that's up on stilts. The more modern architecture at South Pole Station, everything is up on stilts that allows the blowing snow to tend to pass under the building and thereby not accumulate aerodynamically so fast. So apparently that's working. Well, as the weeks went by, the sun got lower to the horizon, the shadows got very long, like this. This is actually one of those buildings up on stilts. And I was so dearly hoping that we would have a clear sunset, but we did not. We had a storm move in per these clouds, and I did not get to see a clear sunset. The reason I wanted a clear sunset so badly was that one of the probably arguably most rare natural phenomena that a human being can experience is the green flash at South Pole Station. Because as I'm sure many of you have seen or certainly are familiar with the phenomenon of the green flash, and I'll describe it very briefly here. Every object in the sky, star, sun, everything is actually spread out like a rainbow vertically because of the lens-like action of the Earth's atmosphere. And so a star actually has a blue, it's a line, it's a spectral line, and it's more evident when the star is close to the horizon. It's blue at the top and red at the bottom, atmospheric dispersion. And that's what creates the green flash. So the very last bit of the sun that is available above a sharp horizon, like an ocean horizon or a frozen snow horizon, that edge, that bit of light is actually being spread out chromatically because of dispersion. And it should be blue at the top, but blue light is scattered. That's why the air is blue, but the green is not so strongly scattered. And that's why when the conditions are just right, the last bit of sunlight is a brilliant green color. Now, the sun doesn't set so fast at South Pole. The sun is moving from right to left mainly, and only slowly going down relative to the horizon. So I know somebody who was at South Pole a year or two before I was, and they had a clear sunset. The green flash lasted for about 45 minutes. The whole world was bathed in emerald green light. I've read the guy's description of it. He was an atmospheric physicist. It sounded like it was just amazing. I sure hoped I'd see it. I didn't get to see it. I was clouded out. So it goes. But after the clouds cleared several days later, we were at least rewarded with a beautiful full moon. And this is a shot of the brand new laboratory that had been built for astronomy, mainly for radio astronomy, but we were using it for the infrared telescope that we had just hurriedly finished at University of Chicago. And I'll tell you about that. Here's a graph. The one graph I'll show, though, it's interesting. Where's my mouse? There's mouse. It's actually data from 1992, but it shows what typically goes on. The darker line is actually red, is some kind of running average. No, pardon me. The red line is a running average. The blue line is the actual day-to-day temperature. So it's days of the year. So it's 1 all the way up to 365 here. And then its temperature, it happens to be in degrees C, and I'm used to F. But so when the sun is high in the sky at South Pole, it's relatively warm. But as the sun gets lower, so here's February 1st, March 1st, right around, what is it, March 22nd or whatever, the sun sets. But as soon as the sun sets, notice how the running average is essentially flat. It's cold as soon as the sun sets. You might have a lot of twilight here because the sun isn't very low below the horizon, but the twilight doesn't do anything to warm you up, man. The average temperature is cold. But what's interesting is the actual day-to-day or temperature is violently changing. And so what is the temperature at these extremes? Well, it's degrees C, but I can tell you these extremes would be below -100 Fahrenheit. And maybe this one here is around -80 Fahrenheit, something like that. But I tell you something funny. When it's -80 Fahrenheit and suddenly there's a windstorm that ocean air blows in, and you have a lot of wind coming in off the ocean, and by a lot of wind, I'm saying maybe it's 30 miles an hour. But when it's 30 and the Fahrenheit and centigrade scales cross over at -40 degrees. So that's, they're the same there. And but when it gets up, when it's around -35 or something Fahrenheit, after you've acclimated to -80 Fahrenheit, it's surprising how warm -30 Fahrenheit feels. It's comical, but it was really true. But the point is, it's interesting how violently the temperature changes.
Hey,
So
John,
yes.
a quick input. The temperature right now at the South Pole is -64 degrees Fahrenheit.
Let's see. Because they're happily in the winter right now because the sun is well into the northern sky. So I am using suddenly my imagination to think about what it's like down there right now, but it's nice and cold. So thank you for injecting that. Let's take a look at the environment outdoors after sunset, but still in the long, lingering twilight. The snow has begun to accumulate around the front door. They are no longer working very hard to dig it out anymore. Let's see. That's right. I remember now. This is the sequence. So there was a day when the temperature was really, oh, truly below -100 Fahrenheit. And I thought I ought to go out and I ought to take a few pictures that I would save forever for just what it was like outdoors, taking a walk around. Now, the extreme cold weather clothing made it surprisingly practical and comfortable to actually go out and take a stroll when it was -100 Fahrenheit. I mean, you really could do it. You could do a lot of things when it's -100 Fahrenheit. But one of the things is it didn't get extremely cold like that unless the wind was very, very low, by the way. But anyway, this series here of me walking around the dome was when it was -100 Fahrenheit one day. And here's a shot. Look at how the snow has blown in and encroached upon the dome. At this point, you see that's that chimney that I told you about when the cook was standing at the bottom of it down here with the open hatch. Here you see the ladder going up the outside of the dome that I used to take that shot looking down the inside with the ultra wide angle. But it's not dark yet, but it was cold and it made for an interesting little stroll. What was it like outdoors after the sun had finally gotten low enough below our apparent horizon to be dark, beyond astronomical twilight? Well, you go out the front door, which was now mainly closed by plywood, but there'd still be a man door there. And you go outside and it was like this. And you'd feel like you were at the bottom of a little crater on the moon or something. It was just so weird. And you'd have to climb up and out. And there you go. And so this was actually a gamma ray telescope that was not officially connected with us, but we collaborated some. It was a University of Wisconsin project. It was built to observe the flashes, the Cherenkov light from gamma ray particles and all the reactions in the Earth's atmosphere when gamma rays hit. But it was tracking the sky, but it's the background stars that, of course, I want to call attention to, because I'm sure most of you all will recognize, of course, there's Canis Major, but of course it's completely upside down compared to how we're used to it growing up in New England. And there's Sirius. What's fun to point out is let's see here. Let me make sure I've got this straight. I get confused because is that Columba? I think this is Columba the dove. Okay, because right down here, if I get my mouse out of the way, you might be able to see there's ever so slightly pink glow down there coming in through that stripe. It's the Orion Nebula. Remember, the celestial equator goes right through the belt of Orion. So the belt of Orion is right here. And so the lower half of Orion going into the southern sky is actually right here. And the Orion Nebula is what, at about -4.5 declination, something like that. So the Orion Nebula was a nice object to look at naked eye when you're walking around outdoors, because if you could clearly see it, then it was helping dramatize to you that the layer of perpetually blowing snow crystals was not terribly thick. Sometimes the wind-blown snow was much higher. You couldn't even see the Orion Nebula 4.5, 5 degrees above the apparent horizon, but we're just barely seeing it here. Well, let's go on with a few shots. One day I was outdoors, and almost every time you go outdoors, there would be some aurora somewhere in the sky. But interestingly, there was not a heck of a lot of aurora from South Pole Station, somewhat disappointingly, because, of course, South Pole is inside the so-called auroral oval. And the maximum auroral activity is in the so-called this region of latitude they call the auroral oval, both in the north and south hemispheres. But in any case, this day when I went outside, lo and behold, there was an auroral arc that was like overhead from horizon to horizon, essentially cutting the sky in half. And I thought, hey, this is kind of cool. So I ran back in, I got my camera, set it up on the tripod, and this arc was just not moving very much. So I snapped the time exposure for maybe 45 seconds or something. I can't remember anymore. But if you notice, I'm going to put my mouse over here near the star, and I'm going to leave my mouse about in that spot, because when I show you, I took more than one exposure, because eventually what happened, suddenly the auroral arc began to move. But because it was moving, I couldn't use such a long exposure. But there you go. See, my mouse is beside the same star. We're not seeing as many stars because it's a shorter exposure. I wanted to keep it short because the arc was rapid. It was moving around, and I didn't want the filamentary detail in the arc to get all smeared out because of its motion. And at least I got something. And so, of course, it was fun to see all the aurora. This shot here, as modest as it is in many ways, was probably the best auroral display I saw of the entire winter over. And you can see that I'm some distance away from the big dome. And there's the light shining up through those perpetually open ventilations and the American flag up there. This is the exhaust from the diesel electric power plant being illuminated by something like a street light off the end of one of the arches and all that. So I was very proud to at least get something. It was much harder to get shots like this back in '94 because most of us had, were film, color CCDs were just not so common yet. And here's a shot showing a meteorological tower that I'm going to talk about in a second. But of course, there's Scorpius upside down, the claws, Antares, the tail, and the stinger, and but all upside down compared to what we're used to. And here's the teapot of Sagittarius upside down, and the spout and the steam coming off the teapot spout and all that, and a Celestron 8 that was there sort of recreationally, which I did in fact try to use. This is perhaps my favorite selfie, because it was my job to climb that meteorological tower quite regularly. Now, I had not been outdoors for probably more than about 4 minutes. I'm about halfway up the tower, and I plan to record a selfie like this with my Nikon camera. And it's the picture is very, very unrealistic in certain ways, because my parka is open, but it's open because I just took the camera out of there. You got to keep your camera warm. Otherwise, it just won't work. I also have taken my big gloves off just to handle the camera. And also I pulled my hood down. With every breath coming out, the humidity coming out of your lungs would make a cell of relatively humid air. And of course, your eyelashes and eyebrows, they're all way below freezing and offering nice little filaments for ice to form on. You would get entirely accustomed to that. It was not really painful, but a little uncomfortable, but you learn to deal with it. If you took your face mask like this off, the Freddy Krueger thing, if you wanted to look at the Milky Way, you could pull your hood back. And to get rid of the claustrophobic feeling, you could pull this thing off your face, and it would last about 100 seconds. After about 100 seconds, it would begin in the ears, the little folds of skin on your ears. That's where you would feel the frostbite, just a little bit pinch, like getting a flu shot. And so you think, okay, that's it. I've seen enough of the southern sky. Time to put the mask back on and button up again. And so it was adventurous and it was fun. because actually, for all the discomfort, it was minor, and it was surprising how well you could function. At the very top of that meteorological tower, that's where this picture was taken from. It happens I have, pardon me, tin cans protecting microthermal sensors to measure rapidly changing air temperature, which could relate to seeing. To make a long story short, a friend of mine, a graduate student in Australia, used the data from this microthermal experiment to calculate atmospheric seeing conditions. The stars really did look like fuzzballs, I'm afraid, from South Pole, because there's a very, very strong thermal gradient. It maybe would be -100 Fahrenheit right down beside your feet. But at the top of this meteorology tower, it would only be about -70 Fahrenheit. So a huge thermal gradient, even going up, I don't know, 50, 60, 70 feet and 50, I don't know, feet in the air, 60 feet. And so with that much thermal gradient and blowing wind, there was a tremendous amount of air turbulence. Unfortunately, my friend who got a PhD out of this data, we assembled the experiment together at Yerkes Observatory. He wintered over a couple of years after me. While he was at South Pole, he died. So there was a certain danger being there. He basically was poisoned by an accidental poisoning that could not be recognized quickly enough to save him. And but I keep telling stories, but I better move on and wrap this up, because there are just so many stories. Some of them, of course, are sad, and that was one of the very most sad. But we learned that with something like a Celestron 8, you could defrost it using acetone. You could wash the ice crystals off the corrector plate with acetone. Acetone would never froze. You'd have to be careful handling it. Like a wad of tissue with acetone, but acetone would wash frost off of optics fairly effectively, and then evaporate away fairly effectively, leaving a usable telescope. But there were a lot of little practical things to be learned. Back at our main lab, where the real action was, this fellow was Joe Spang. He was operating the Trenkov telescope, the gamma ray telescope, but he was our good friend. And it happened that comet Shoemaker-Levy 9 was crashing into Jupiter that year. We had just built this telescope. It was a very intense effort with a small team of people, and I'm proud I was part of the team, drilling and tapping holes and everything for this thing. That's a long story in itself, but it was an F10 infrared Cassegrain with a big infrared camera. It's actually an equatorial mounting, although it looks out azimuth. But Joe Spang helped us very intensely operate the telescope during the week or so the Shoemaker-Levy 9 comet fragments were crashing into Jupiter. And anyway, here's the baby buggy-like observatory shelter folded away from the telescope. It looks like a blue sky daytime with cirrus, but it's not. Those are actually auroral arcs, and there's some moonlight out for this shot. And it's a pretty crazy looking telescope, but believe it or not, it was an F10 Cassegrain. You could flip a mirror in there and bring the focus out to an eyepiece. That's what you're looking at there. And I think that was a Celestron 11 piggyback on it as a finder, and it with a big insulation package on the CCD. The problem was keeping some of your electronics warm enough to operate at these extreme temperatures. So we got a lot of publicity. It was not really our official science goal, but who could resist? This is the disk of Jupiter, and which is not very bright at around 2.4 microns. The Galilean satellites, however, shine very brightly in the near infrared. There was a little lingering light in the atmosphere of Jupiter where fragment G had impacted maybe 12 hours before, but we had timing predictions with a standard deviation of typically about 3 minutes from Jet Propulsion Laboratory when to expect each fragment to hit. So we'd get out there 30 minutes ahead of time, expose the telescope, clean off the snow or frost or whatever we had to do, and we'd start snapping pictures. And sure enough, right on schedule, something started to happen. And sure enough, there was fragment H. These were short exposures. We had to literally click the keyboard in the warm room to make them happen. And then just a few exposures later, the detectors being overexposed. And then finally, with the passage of time, the energy from fragment H would dissipate. And another young fellow got a PhD with the data from Shoemaker-Levy 9 hitting Jupiter. So that was gratifying. It's always fun taking the data, letting somebody else reduce it. Anyway, dear friend, Kerry Vigue was our winter over electrician. This is what you look like before you go outside. This is what you look like after you've been outside for 30 or 40 minutes and come back in again. Notice that all the wires hanging out of his camera. He had a Canon, but it was mainly plastic. A lot of plastic gets incredibly brittle down around -80 Fahrenheit. So the camera still worked, but where he had a flash unit or something, just broke the top right off the damn camera. What was Kerry doing when I took that picture? Well, for this shot, I am outdoors. Remember the dish and the communications engineer on top of that building? That's where I was when I took this shot. I'm up in the air and I'm looking out at the horizon. That's the moon overexposed. What are these lights? They are diesel fuel campfires. According to what I remember, believe it or not, it was actually 300 feet between these diesel fuel campfires going way off in the distance there. But I hope you can see over the crappy link, there's a blinking red light in the sky. Blink, 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 blink. That was a big Air Force cargo jet flying overhead with the door open, doing our midwinter airdrop. They're pushing crates out the hole with parachutes, trying to get the crates to land in the drop zone. They did it as a training exercise, but of course, it was important to us for morale and also for sometimes very critically needed equipment. Our liquid nitrogen generator failed and it had to be rebuilt. And it would not have been possible had we not had midwinter airdrop. So there were about 27 packages like this. And the packages were picked up with the tractor. People like Kerry would go out with flashlights, direct a tractor with its big scoop to where packages were found. And they'd get physically pushed into the scoop of the tractor, and the tractor would drive into the dome where there was a team of people to open them up. And that's what's going on here. This is Ed again, our chef, opening them. And so the packages, all about 25 or 26 of them were disgorged out there, and the contents very quickly carried indoors into the middle of the galley, the dining room with all the chairs removed to try to, to survey and to see, and surprisingly, although you could see some things were smushed, pretty much everything came through. Vegetables, mail from loved ones, gag gifts for morale, all kinds of things, and including very important, scientific replacement parts. It all worked. This guy was driving the tractor, and he's got particularly rosy red cheeks because this was in fact the worst case of frostbite all winter long because he didn't bother to put his Freddy Krueger mask on when he was repeatedly jumping out of the tractor to help guys push the boxes into the big scoop. So he got a little bit too exposed on his cheeks, but he recovered fine because it was quite superficial. Well, here's just another shot of a distant berm, some things in long-term storage through the winter. Sagittarius again, pardon me, Sagittarius and Scorpius. The camera's shaking because the wind in this time shot. But let me segue finally, wrap this up. There were 3 of us in the small team. This was the first team for the CARA organization having winter over staff with equipment. My other team member was John Kovac, and he's a professor at Harvard, and he was in charge of operating this thing. This was a bolometer, a sensor for a small radio telescope studying the cosmic background anisotropy. And this is the blue thing here that he's looking at with this thing is actually a pool of liquid nitrogen as a calibration source. And so there had never been an experiment wintered over at South Pole as complicated as this. And there were many difficulties making this thing work outdoors. But in this shot, John is smiling just a little bit because we're already getting near the end of the winter, but he was beginning to make this thing work. It had been back and forth outdoors, but because there's just, in some places you've got to add heat, in other places you've got to remove heat to keep vacuum seals working in these extreme temperatures. It was tricky, and it had to be worked out empirically. Our other teammate, Hien, is there. He was really the station science leader. He'd just gotten a PhD from Princeton, I think it was, and John had was just graduated with an undergraduate degree in mathematics from Princeton. Anyway, it was working, and we carried it back outdoors again to install it in this thing. This is actually the shelter of a radio telescope for cosmic microwave background radiation. That thing down there is actually the radio telescope. The big structure is not like a telescope dish. It's a sky shield. It's aluminum on the inside to keep radiation from the ground and earth from interfering too much from the incredibly sensitive and relatively small radio telescope down here. And there's John, because he not only had to worry about that detector, but he had to worry about trying to make this mechanism work and track the sky. And it was a very formidable thing. And his effort along these lines was nothing less than heroic. But I fear that the sun had already begun to return, and he got some data at the very end of the season, but we were running out of time. And I'm just going to wrap this up by showing you a twilight sequence, compressing a great deal of time into this, because the twilight changes very, very slowly as the light returns. It's not like in the science fiction movies where the darkness falls immediately at South Pole Station. That was one thing about John Carpenter's The Thing that was wrong. This shot right here, Jupiter was lined up, the moon was lined up with the planet, I guess it was Venus, and taking that picture from South Pole Station really made me feel like a Stanley Kubrick moment, you know, with a lineup like that from being at a place like that. But unfortunately, our sunrise was clouded out again. No green flash for me, but it was exciting to see the long shadows when the clouds cleared. There were many chores related to station opening, basically an explosive charge breaking ice crystals off the inside of the dome, catching up with a haircut, a friend in the background laughing. It was a happy winter over. We got along, we had a lot of laughs. The emotionally, it was basically an unusually happy group. I think the picture looks a little preposterous because both the gal who was a communications tech and Joe, they're both wearing these preposterously large extreme cold weather boots. But this is not staged. This is not the shoes aren't on there to be funny. We wore them by now. We wore them all the time like slippers. You acclimate to them completely, and they actually become incredibly comfortable, even if they're giant, big, clunky things. Thumper Porter was his nickname, and he was a general maintenance mechanic, and he took the prize for the most impressive winter over pants. Finally, the first plane returned. Everybody is outside again. And it's a very emotional moment, but the emotions are quite different. Janet Phillips was our station manager, and she had the privilege of this choreography of hand signals to park the first plane as it comes in. And by the way, finally, in the distance here with my mouse on the left-hand side, that's that, at least in 1994, that American flag and that sign marked the actual South Pole. The ice is moving something like 20 feet, or is it 20 meters every year? So right now, the South Pole is much closer and maybe even beyond where Janet happens to be standing. But the plane comes in. Oh my goodness, it's so big. The noise, the smell of the diesel, the noise. It's very, very dramatic. And on one hand, we're feeling really burned out. We're very, very eager to get out of there. But on the other hand, we realize that our unique place there, and we're leaving it. It's become our home. You bond with being there in a certain way, as eager as you are to leave. But there's a regret because you felt very special being there. It is such a unique place. But soon all that is coming to an end. So emotionally, it's an interesting time as this thing comes in. But with that signal right there, she is symbolized in the end of the winter over, because she is indicating to the pilot he's parked perfectly, he can feather his props, and the new crew comes tumbling out and meeting up with us, and it's hugs and kisses all around, and the cycle of activity at South Pole Station begins again. Thank you very much for your attention. With this long-winded talk, it's hard to compress an experience like this into a short talk, because it was a long time, very intense, but I so greatly appreciate your attention. Thanks.
Well, John, that was fantastic. I thought I didn't like the cold here in New England. I can't even imagine how cold it must get at the South Pole. And like I said, I just called up on the weather app. I told you in an email that my grandson is thrilled about weather. And that's why I have the South Pole Station data on my app. It's minus 64 degrees Fahrenheit. Indoor humidity is 0%.
Yeah, yeah.
So
I almost forgot to say, or maybe it's said in the text, that the coldest that got my year was negative 106.6, I think, and in the text I rounded that up to negative 107 Fahrenheit. Now, that is not including any wind chill or anything like that. If you actually apply the wind chill formula, which I think is actually sort of meaningless down there, but the formula can give you more like a negative 180 when we were there. And but it was really surprising how well we could function doing things outside, like John Kovac working on that radio telescope, even during those extremes. You just have to learn to be very patient. Everything you want to do takes one hell of a lot longer, but you learn to live with that. And if you can do that without going too crazy, you can still get things done.
that's fantastic. You know, I'm glad you mentioned the orientation of the sky. when we, you can play with it nowadays with computer apps. You can take your computer planetarium program and go to the South Pole or go to the North Pole. When I was a kid, one of my all-time favorite jobs was I worked at the planetarium at the Worcester Science Museum, I think it was called the Ecotarium. And when we weren't doing shows, I had the luxury of being able to take that planetarium projector and turning it so I was at the South Pole or turning it so I was at the North Pole, and just let time fly by. The moon is up for 2 weeks at a time, and then it's set for 2 weeks at a time. When the sun comes up, you're right, the green flash lasts a long time because the sunrise is really, it spirals above the horizon.
It rises, effectively mainly parallel to the horizon. And so you potentially have these long flashes that are just incredible.
Sure. And look at the visibility of planets. Jupiter is above the horizon for 6 years. And then it's below the horizon for 6 years, right? As it orbits the sun. It's a really bizarre, look at the sky and how it all works. And you're right, the constellations look upside down. So does the moon, right?
Everything was screwy. It took a long time getting used to it. And but I had a Norton Star Atlas with me. And one thing I did is I made a point of going out and pulling that Freddy Krueger down, enough times. I identified every southern hemisphere constellation in the sky while it was down there. I'd been in the southern sky before, but even though I don't remember all those constellations at this point, I made a point of identifying every single one with the help of a good old Norton Star Atlas.
That's awesome.
So it was fun to do. Before I forget, my friend Bob Toop has, via the chat session, was inquiring about the Enchanted Sky Star Party, which is something we hold out here in Magdalena. It's an annual event. We had up to as many as 120 or pushing 130 participants before the pandemic. Through the pandemic, we continued to operate the Star Party for local people in a very modest way. We hope to continue to have the Star Party this year, but possibly, and again, in a very low-key way. But folks are always very welcome to come visit out here. There's a lot to do and see in New Mexico. We have a dark sky. We've got a friend 60 miles west of us with a brand new 40-inch Dobsonian in a gigantic roll-off roof observatory. It's a spectacular, I've had a chance to see a lot of good things through a telescope, but looking through this 40-inch, it's about f3.5, I think. He's got all fabulous eyepieces in a very, very dark sky, like 7,500 foot altitude. There's a lot of things I've seen out there that I've never seen him like that ever before in my life. So, and he's very friendly. Jamie Todoriot, oh goodness, now tongue twister. But my friend Jamie has got this 40-inch. He's very friendly. And some of you come on out, and if Jamie's around, we'll visit him. So feel free.
Hey, John, before I open it up to questions, let me do my end of the meeting thing. I'm not even going to keep sharing your screen in case you want to go back.
Oh yeah, no, stop share. There we go. Yeah.
No, don't stop. You can keep sharing if you want. I was just going to.
No, it's okay.
Then let me put my screen back up. And go one over here, just to remind folks then that, as I mentioned earlier, the next board meeting is going to be next Thursday evening at 8 o'clock. I'll send out Zoom invitations on Sunday. Members are welcome to sit in and listen and watch the proceedings. Our next monthly meeting is going to be on Thursday, April 14th at 8 o'clock, and I hope to see everybody there.